guys know anything about Advano, but Advano is a silicon carbon composite startup that brings a ball milling process with a license out of Tulane University to nanostructure and create a surface area that is highly dispersible within a carbon matrix, enabling us to manufacture a silicon carbon composite at a much lower cost position than the silane gas alternatives that are out there. And as far as we know, at the moment, we're the only ones actually playing in this game this way in the Western world. So this is our goal, and I'll go ahead and see about sharing things here. Window. I'm going to walk through this presentation very quickly, but I really want to get to how do we make this marketplace actually happen in a mass concept, not in a lightly participant, high-end vehicle marketplace. So today's battery industry challenges are very clear. We need to improve battery performance. Supply chain today is nearly 100% dependent upon Chinese raw material sourcing, especially on the anode side of the batteries and synthetic and natural graphite. And then the costs are too high for mass adoption. And this is a challenge for EVs long into the future. The limiting factor of batteries is graphite. They've maxed out the ability to hold energy, and graphite can't really hold much more than what's already in LGs or LG Energy Systems or Tesla's or Panasonic's or SK's batteries. So how do we figure out how to improve their energy density, their speed of charge, and get longer range with these at a lower cost? So this is where Advano comes into play. We're a 7-year-old company developing this technology over the past few years, but now we're finally enabled with the team of people that has been assembled over the past 6 months to get ourselves launched into this marketplace with our industrial pilot to bring a silicon carbon composite material for adoption and commercial activity at a small percentage of the active anode materials. You know, we're looking at 5, 10, maybe up to 20% of replacement and gaining roughly a 5, 10, maybe up to 25% energy density gain. So this is a massive potential marketplace. Globally, it's nearly $30 billion by 2030 timeframe. There's a initiative within the United States and within Europe to transition away from all the sourcing coming from China. There's a need for next generation materials to drive the performance gains, but it has to come at a lower cost and be scalable. So Advano has positioned ourselves as a safe alternative, not producing silane gas, low carbon footprint, and a local supply of raw materials that can be sourced and are sourced from direct mines for silicon and manufacturing of high purity silicon in advance of silane production, or goes to silicone production, or can come directly to us and we nanostructure it to incorporate it within a carbon matrix and make it an actual viable solution for silicon. This is a neat little slide here to basically talk about what the differences are. we can create a low cost, roughly 1/3 the price point of where silane gas SiC materials are, and probably a little bit lower than SiOX materials. Process safety, we're not using silane gas, and we're not going to be transporting silane gas anywhere, so that's going to give us an extremely an extreme benefit versus silane gas potentials in our manufacturing process and raw material supply.
I'm sorry to disturb
sorry
you.
to interrupt, but there's no change on your presentation.
Yeah, it's not in the presentation mode.
It's not? Oh, sorry.
Yeah, the slides were not moving.
Yeah,
Thanks.
that's good.
Oh, why is not in presentation mode? It says stop sharing. So this is weird.
At the bottom right of your screen, there will be like a little kind of projector. If you click that, it will go into presentation mode, like a projector screen on a stand, all the way at the bottom of the page.
No, I know that. It's doing that on my screen here, but it's not uploading into this.
That's weird.
Are you guys only seeing
slide 8?
Seeing any of it?
We're seeing slide 8, the competitive advantage.
Oh, okay. So you're not seeing what I have as the okay. Well, let me
Yeah, it kind of stayed in the first slide itself, and then when you exited the presentation mode, it came down to the 8th slide.
Okay.
Okay, sir. Are you connected to a different monitor?
I think it
has.
That usually happens when you have like 2 displays.
I don't have 2 displays. I only have one, and mine has it in presentation mode. You only have it in.
It might just be laggy. Like, what if, like, you know, you not sign out, but like leave the session and come back to the session? I don't know if that could help.
Okay. Let me try, because I just escaped out. Let me.
And something that can happen too is when you put the presentation mode. Oh, I think he went out.
Sorry, guys. I think he took my advice.
Yeah, I think the problem is that, you know, when you use the Google Meet system, you can share. Oh, hello, Christopher.
I'm back.
Hello.
I was hearing you guys the whole time, but you couldn't see me.
No.
Good thing it was all good things.
I think maybe the problem is like when you put the presentation mode, it will open like a new tab. Maybe you have to share that tab instead of the original PowerPoint.
Okay. Well, let's try this. So you all can see this right now?
Yep.
Okay. What if I don't go into presentation? Would that be all right?
Sure.
Yeah, sure.
Okay. So let's stay going like this. All right. So sorry about that. Anyway, I don't need to talk about competitors too much, but we will be able to build out a commercial site and scale a commercial site much more rapidly and more cost effectively by far than our silane gas competitors. So what has been going on in the last 6 months is we brought in a team of people that are not only focused around the science of silicon carbon composites, but actually understand what we're trying to do functionality wise for commercial opportunities. And we're focused on customer feedback in direct sampling over and over again. Nobody's going to have the right solution right off the bat. And so anybody who says they produce something and then throw it across over the fence to a customer, they're going to tell you it didn't hit all the qualifications or specifications. That's fine. The question is, do you have follow-up questions on that as to what do you think happened? What did you see happen? What if we try this? What if we try that? And move forward. What we are now doing here at Advano is producing 2 bookend materials that one in our REALSi 1 is a long cycle life material, over 1,000 cycles, and still yields about 1,400 milliamperes per gram in capacity to compare with SiOX. Then we're developing another product that is based upon 1,850 milliamperes per gram at minimum and enable significantly higher capacity and greater energy density gains, both volumetric and gravimetric. And it should be putting us in a position where we're able to capture the marketplace in opportunities that need specific design for their ecosystems to enable the level of performance enhancement that they're looking for with the offset of cyclability that is typically there, because silicon is about 1/3 to 1/4 of many cycles as synthetic graphite is. So what we've been doing recently, original Advano materials were producing a D50 of about 150 to 120 nanometers in size. We have now gone back and learned to restructure down to 60 nanometers in size with D50, and we're able to condition the surface of our materials to reduce the amount of oxygen and enable them to be highly dispersible within a carbon scaffold that we have redesigned as well. It is a porous carbon matrix made of both soft and hard carbon. And then we're finding right now that porous structure you see there in the middle essentially needs to be filled, and to cover up any exposed direct exposure of silicon going forward. And so we're producing now through CVD coating mix, conformal coating to reduce the surface area down to 2 to 3 meters squared per gram. And we've been able to see a significant improvement in our first cycle efficiency and capacity by doing this. And this is what we're really tackling today, is to make sure that we can manage the issues of silicon swelling through the nanostructuring down to 60 nanometers in size, and creating the right recipe of the microcomposite design in our carbon matrix going forward. Ultimately, we believe that REALSi 1, the replacement of SiOX, should be available by the end of September, and scalable within our industrial pilot plants that has been commissioned over the month of July and is ready to produce up to 70 kgs in a single batch. And a batch usually takes somewhere between 28 and 35 hours of time. And that 70 kgs is plenty to go through A sampling and B sample qualifications over the next 2 years. Ultimately, we want to scale to a commercial size and a commercial entity of a 3,000 ton plant to start. We're agnostic to location. We're looking for low carbon footprint energy, and we're looking for low cost energy. Very similar foundations to the graphite teams. So we want to be a part of a combined solution with graphite to enhance the energy density of today's batteries and transition ourselves into roughly a 20,000 ton commercial site, which I believe personally that should be somewhere around 1/3 of the marketplace in North America alone by 2030 timeframe. And helping us through this design phase is Dr. Shirley Meng. She is on our board of directors and a technical advisor to our team. She spends a great deal of time tied with our CTO, Dr. Sung Lim, who spent a little bit of time at Lighten Corporation, LG Chem back in his early days, and Sila Nanotechnologies. So the question is, for me, is how do we get real about the things that we have to go through as startup operations without a parent company with revenues behind them, when qualifications take a long time and you need to raise a boatload of money. Everybody is focused on raising money right now to gain money in I won't say easy things, but less nuts and bolt things like AI and software. But the economic ecosystem of first world countries is all oriented around energy and transportation. And this stuff is not going to go away. And what EVs ultimately are doing are enabling the ability to reduce the carbon footprint through that transportation that does occur, that enhances commerce and economic development, giving jobs and money to our population to make sure that we're staying as a first world organization. You know, this is a capital intensive marketplace. Gigafactories cost billions of dollars. And those material suppliers of graphite and silicon carbon composites are billions of dollars as well. But I'm telling you right now is we believe our 20,000 ton plant should be able to produce, should be produced with roughly $500 million to $600 million in total capex for 20,000 tons, which will enable us to have a price point below $50 a kg as soon as we start. You know, there's a whole lot of issues right now in fundraising. Financing is extremely difficult. The DOE has the grants, the bipartisan infrastructure law 3099 grants that are out there. This is great, except the minimum for a greenfield site is a $100 million investment for a $200 million project. And you have to have offsetting dollar for dollar match of those grants. This makes it very challenging for startup companies that actually can get into the game and space if enabled. And the issue is how does private money get into this game along with the non-dilutive funding potential or even the loan program office there to support to enable a Western world development of materials. And this is, you know, the marketplace concern right now for everybody in the battery materials world is how do you take the time and make the investments to get into the game. And as Wayne Gretzky once said a long time ago, you miss 100% of the shots you never take. So there are a lot of companies out there like ourselves that are taking shots, but we are sitting here waiting for a whole lot of financing to actually take their shots on goal, or even taking a shot and swing to enable this to happen. The money of the past has dried up, and it's not the same way as it was in 2020 and 2021. But the game hasn't stopped. EVs are still going to be a solution for the future. And how do we get into this? And with that, I'll stop sharing. And let's have a discussion.